Okay, so this problem is basically the same as the other ones we've done. We're going to take silver nitrate and we're going to react it with calcium chloride, and we're going to get silver chloride solid plus calcium nitrate. Okay? Now, normally we would write the complete ionic equation in the net. I'm going to go ahead and I'm going to start part A, and I'm going to solve part A using this equation rather than the net ionic. I'll use the net ionic later. Okay? So what we're going to do also is I'm going to put kind of a laundry list of all the things we know about each thing. So we know we have 100 milliliters of that, and it's 0.20 molar. And we know so this was in the problem, right? You would read the problem just like yesterday, and that's what it said. A, calculate the mass of precipitate formed. B, what's your yield? C, calculate the concentration of all your remaining ions. And that's exactly what we're going to do. But this time, instead of going through my ions, I'm just going to do it directly from this equation. I'm going to find out how much of this I have and go to product. And I'm going to find out how much of this I have and go to moles of product and see which one is limiting. Okay? So I'm going to start down here with silver nitrate. And I've got 0.100 liters of silver nitrate. 1 liter of silver nitrate is 0.20 moles. That's from here. Now, I'm going to put a little squiggly line here, and I'll show you why in a minute. That gives me 0.02 mole silver nitrate. Now, once I have this, I have more information as well. I have 0.020 mole here, right, of this. And if I know that silver nitrate goes to silver, 1 silver and 1 nitrate, if I have 0.02 moles of that, how many moles of silver ions am I going to have? If I have 0.02 moles of this, how many silver ions? 0.02. And if I have 0.02 moles of that, I have 0.02 moles of nitrate. Oh, wow. So this is going to come in handy later, isn't it?
Yes,
all right.
It is.
Okay. All right. So now what we're going to do is what we always did before. We're just going to go to product. We're going to go to silver chloride. In my equation, for every 2 moles of silver nitrate, I get 2 moles of silver chloride. So I'm just going to write it. You can write 1 to 1 if you want. And that gives me 0.020 mole silver chloride. All I did is what you did in pre-P. I went from here to here. The only new part is that. All right. Now we're going to go to find the limiting. We're going to go from here to here. Same thing. Okay. So I'm going to take calcium chloride. And I've got 0.100 liters of calcium chloride. 1 liter of calcium chloride is 0.15 mole. Calcium chloride equals, I'm putting this squiggle here because I want you to stop and do some work. Okay. Now this can be handy. I know, I'm going to put this up here, that calcium chloride goes to 1 calcium 2 plus 2 Cl minus, doesn't it?
Yes.
So if I have 1 mole of this, or 0.015 moles of this, how much calcium am I going to have? 0.015. So I have 0.015 mole of calcium chloride, 0.015 mole Ca2 plus. How much Cl minus am I going to have? 2 times that, right? Good, very good. Yeah, that's 0.030 mole Cl minus. Y'all did good. See how we're doing things in our head today that we wrote out on paper before. We're shortcutting it. If you feel like you can do that, this is a great, we're almost done with everything right here. All right, so I'm going to go right to mole. 1 mole of these gives 2 moles of those. So 1 mole of calcium chloride gives 2 moles of silver chloride. So that's 0.030 mole. So, which one is my limiting? Good. My silver nitrate. So what I'm going to do is I know now that I'm going to make 0.020 mole of this, because that's what my limiting tells me. Easy, right? Not bad. Basically what we did yesterday almost. Okay. Now, I know what my limiting is. I'm going to take this one and go to grams. Of course, you could have gone to grams all the way if you wanted to before. So I've got 0.020 moles of silver chloride. 1 mole of silver chloride is 143.32 grams. And that's 2.87 grams silver chloride. And I'm going to put that up here too. Easy. Okay? All right. Now, I'm not going to do part B. Part B is just going to be actual over theoretical, which is this times 100. We're going to move on to C. Okay. Now, I've got all this information, so this is going to make C a piece of cake. Let's start off with our easy ones first, right? So our laundry list of ions is going to be, if you look at my reactants, I can make a laundry list. I've got silver, nitrate, calcium, and chloride. So I'm going to list them all. Silver, nitrate, calcium, and chloride. How do I get that? I didn't write it all out, but I know these are all dissolving, aren't they? Now, what one can I cross off the list? What was limiting? Right, so which ion can I cross off? Good, because here's my net ionic. So we're going to write our net ionic here rather than up at the top. This is my net ionic right here. So I don't have to worry about that one. It's done. Because all of this is going to be used. Every bit of it. Now nitrate is still left over, because nitrate just sits around. But all the silver's gone. It's all here. Okay, so let's do nitrate then. Well, what did I do up here? What is the number of moles of nitrate I have? 0.02. So all I have to do now, 0.020 mole. Now, what is my volume here? 100 plus 100, 200. So I'm going to divide it by that many liters, and that gives me 0.1 molar. Isn't that nice? Easy. Let's look at calcium. I already have it up here. 0.015 mole calcium. So I'm going to put 0.015 mole divided by 0.200 liters, and that gives me 0.0075 molar. Oh, whoops, just 1 O, sorry. Okay? Chlorine's the hard one, isn't it? Right? Because chlorine is going to be what I started with minus what I used. Oh, but I have what I started with too, don't I? That's up here. I started with 0.030 moles. All right? So I'm going to put that here. 0.030 mole. Now, how much did I use? Okay, I'm going to find out how much Cl is in my AgCl. I found that I made, and I put it here, 0.020 moles of this, didn't I? Let's go from this to Cl minus. How much Cl minus is in here? Simple conversion, because that's where it is. So I'm going to take 0.020 mole silver chloride, and for every 1 mole of silver chloride, I have 1 mole of Cl minus. That's 0.020 mole. So that's my used. I subtract, and that equals 0.010 mole. I divide that by 0.200 liters, and I get 0.050 molar solution. Okay, so that's the end of, hang on one second, that's the end of that problem. So I'm going to go ahead and hit stop.